Every day, your life runs on systems you never see. Lights turn on, water flows, phones connect, food appears on shelves. None of this is automatic. Invisible infrastructure works non-stop to keep everything stable. When one system fails, normal life breaks instantly. To understand how modern life really works, you need to see the systems you depend on every day.
Electricity is the base system that allows modern life to function. Power plants generate electricity using coal, gas, nuclear fuel, water, wind, or sunlight. This electricity must be used the moment it is produced because large-scale storage is limited. High-voltage transmission lines carry power across long distances from generation sites to cities. Substations then reduce voltage and redirect electricity into regional and neighborhood distribution networks. From there, electricity enters homes, offices, hospitals, factories, and communication infrastructure. The power grid must remain balanced every second. Supply must match demand exactly. If demand rises suddenly or equipment fails, protective systems shut down parts of the grid to prevent damage. When electricity stops, internet routers lose power, water pumps stop, transportation systems slow, and payment systems fail. Electricity feels invisible only because it usually works without interruption, but it supports nearly every system you depend on every day.
Clean water reaches homes through a continuous and pressurized system that never truly stops. Water is collected from rivers, lakes, reservoirs, or underground aquifers. Treatment plants remove debris, bacteria, and harmful chemicals using filtration and disinfection processes. After treatment, pumps push water into large underground pipes and elevated storage tanks. Pressure inside the system allows water to reach homes, even in tall buildings. Sensors constantly monitor water quality, pressure, and flow. The entire system depends heavily on electricity to power pumps and treatment equipment. If power fails, water pressure drops quickly and service can stop. Without clean water, sanitation systems fail, hospitals struggle, and firefighting becomes extremely difficult. Flowing water feels simple because the system is designed to stay hidden. In reality, it requires constant monitoring, maintenance, and energy to remain reliable every minute of the day.
The internet is a physical communication system built from cables, routers, and data centers. When you open a website, your device sends a request through a local router into your internet service provider's network. The information is split into small packets that travel through fiber optic cables as pulses of light. Routers along the way read packet addresses and decide the next path based on traffic and availability. Data can cross cities, countries, and oceans using undersea fiber optic cables. At the destination, servers inside data centers process the request and send data back using the same packet system. Wireless connections only cover the final few meters between your device and the router. Beyond that, the internet depends almost entirely on wired infrastructure. When cables are damaged or servers fail, connections slow or stop. The internet feels instant only because millions of machines constantly coordinate to reroute traffic around problems.
Food reaches cities through tightly coordinated supply chains that operate continuously. Farms grow crops and raise livestock according to seasonal cycles. Processing facilities clean, package, and preserve food so it can be transported safely. Logistics networks move products using trucks, trains, ships, and airplanes. Warehouses store food briefly before distributing it to retail stores. Inventory systems track demand so shelves are restocked just in time. This system depends on fuel, electricity, refrigeration, labor, and accurate timing. Most supermarkets only hold a few days of supply. When transportation breaks or processing slows, shortages appear quickly. Empty shelves reveal how dependent cities are on constant movement and coordination. Food systems feel stable only because every step works together precisely. When one link fails, the entire system becomes visible through disruption.
Transportation systems move people, food, fuel, and materials through coordinated infrastructure. Roads carry cars and trucks under traffic control systems that regulate speed and flow. Sensors, cameras, and traffic lights adjust movement to prevent congestion and accidents. Rail networks rely on signaling systems that track train locations and manage safe spacing. Ports coordinate ships using schedules, cranes, and logistics software to move cargo efficiently. Airports depend on air traffic control systems that manage takeoffs, landings, and flight paths. Fuel supply keeps vehicles moving across all transport modes. When one part of the system fails, delays spread rapidly. A signal failure, accident, or fuel shortage can disrupt entire cities. Transportation feels routine only because monitoring systems, control centers, and maintenance crews constantly manage risk and correct problems in real time.
Modern money depends on digital banking systems rather than physical cash. When you pay with a card or phone, the transaction travels through secure communication networks to banking servers. Banks verify identity, check balances, and approve payments in seconds. Clearing systems then settle transactions between financial institutions continuously. This process runs all day, every day. Payment systems rely on electricity, data centers, encrypted networks, and precise time synchronization. When any part fails, payments stop immediately. ATMs shut down. Card terminals go offline. Online purchases fail. Cashless convenience increases speed but reduces tolerance for outages. Trust in money now depends on infrastructure reliability more than physical currency. Banking feels stable only because layers of systems work together without interruption.
Healthcare systems depend on multiple invisible infrastructures working together. Hospitals require continuous electricity to power ventilators, imaging machines, lighting, and monitoring equipment. Clean water supports sanitation, sterilization, and patient care. Digital networks store medical records and connect diagnostic devices. Supply chains deliver medicines, oxygen, and equipment on precise schedules. Backup generators provide limited protection during outages, but they cannot run indefinitely. When infrastructure weakens, healthcare capacity drops quickly. Delays in power, water, or data access can directly affect patient outcomes. Hospitals appear calm only because many systems remain stable under pressure. During large-scale failures, infrastructure problems can turn medical emergencies into system-wide crises.
Precise time is one of the most important invisible systems in modern society. GPS satellites provide extremely accurate timing signals, not just location data. Communication networks use time synchronization to keep data packets in order. Financial systems rely on precise timestamps to verify transactions and prevent conflicts. Power grids depend on synchronized timing to balance electricity safely across large regions. Transportation systems use time signals for navigation, coordination, and scheduling. When timing signals degrade or fail, systems do not collapse instantly. Instead, errors accumulate quietly. Data becomes misaligned, transactions conflict, and coordination weakens. These problems are difficult to detect at first, but spread across connected systems. Timing infrastructure is rarely noticed because it usually works perfectly. Modern life depends on shared, precise time being delivered continuously from space-based systems.
Emergency response systems must function instantly during crises, but they depend on fragile infrastructure. Emergency calls travel through communication networks to dispatch centers. Dispatch systems identify caller locations, assign resources, and coordinate response teams. Ambulances, fire trucks, and police vehicles rely on roads, fuel supply, navigation systems, and traffic control to reach incidents quickly. Time determines survival during medical emergencies and disasters.
When supporting infrastructure fails, response slows immediately. Power outages can disable call centers. Network failures can prevent location data from updating. Fuel shortages can limit vehicle availability. These systems are designed with redundancy, but redundancy has limits. Emergency response feels reliable only because electricity, communications, transportation, and time systems are all functioning correctly at the same moment.
Modern life works because systems are deeply interconnected. Electricity powers communication networks. Communication networks control banking, transportation, healthcare, and logistics. Logistics systems deliver food, medicine, and fuel to cities. Each system depends on others operating correctly at the same time. Efficiency has made these systems faster and cheaper, but it has also reduced buffers and backup capacity. When systems are tightly connected, small failures can spread rapidly. A power outage can disable mobile networks, stop digital payments, shut down water pumps, and delay emergency services simultaneously. Stability does not happen automatically. Engineers constantly monitor performance, repair damage, update software, and adjust operations. Maintenance crews work every day to prevent failures from spreading. The world feels stable only because breakdowns are managed continuously. Modern society is not held together by simplicity, but by constant effort to keep complex systems balanced and aligned.
Modern life feels simple because complex systems work perfectly together. You rarely see them, but you depend on them constantly. Once you notice these systems, you start seeing the world differently.